Let's look at a familiar scenario for AEM developers. You execute a search operation, and instead of immediate results, you get an endless loading spinner. Users are frustrated, and the application grinds to a halt. By the end of this, you will know how to construct a custom index fully compatible with AEM as a cloud service, and how to write a paginated query that returns data in milliseconds. To follow along, you need an active AEM SDK or cloud environment, your IDE of choice, and access to the developer console. Guessing at indexing strategies is one of the fastest ways to degrade system performance. Mastering these specific configurations ensures your deployments rely on guaranteed technical logic, not trial and error. When you run a search in AEM, Jackrabbit Oak's query engine evaluates the available indexes. It estimates the effort required for each path and routes your query to the index with the lowest numeric cost. This routing logic leads to a very common trap. Developers often create a fully custom index specifically for the DAM asset node type to meet a narrow project requirement. Because this new index is highly specific, the Oak engine calculates a lower estimated cost for it compared to the default system index. It routes all asset queries there, which inadvertently breaks the global OmniSearch functionality. This documentation shows the difference. Top, the improper custom index on the DAM asset node. Bottom, the correct approach customizing the OOTB index. Copy the OOTB index, target the index rules node, and place new properties, like this tags property, inside the DAM asset rule. Embedding your rules into the OOTB index ensures the global repository search continues to function exactly as expected, while successfully supporting your custom business logic. AEM as a cloud service enforces a strict naming convention for these customizations. Your index must follow the format of the original OOTB name, a dash, the product version, dash custom, and then your custom version number. Once the index is named correctly, you can optimize its footprint. By default, AEM uses Apache Tika to extract the full text from the inside of documents, like PDFs and Word files. If your business requirements don't include searching the internal contents of those files, you can disable Tika. You do this by adding an unstructured node specifying the exact MIME types to exclude. Removing this text extraction process significantly decreases the time to build the index and reduces the amount of cloud hardware consumed by the repository. With the index defined, we move to the project codebase. Cloud Manager CI/CD pipelines treat index changes with intense scrutiny, requiring strict atomic deployments. This XML configuration shows the project's top-level pom.xml file. You must ensure the Jackrabbit File Vault Package Maven plugin is updated to version 1.3.2 or higher. Next is the Properties block. You must set the Allow Index Definitions parameter to True to explicitly authorize the deployment package to modify the indexing structure. Below that, setting the No Intermediate Saves flag to True forces the repository to apply your configuration as a single transaction. If you skip these specific Maven properties, the Cloud Manager CI/CD pipeline will reject your deployment, even if the index definition itself is written perfectly. Now that the index is successfully deployed, you need to extract the data. We'll use the Query Builder JSON servlet to execute the search safely. When dealing with a large repository, asking the system to return every single matching result all at once will rapidly consume all available memory. This documentation outlines a critical warning. You must absolutely avoid setting the parameter p.limit to -1. Iterating through hundreds of thousands of results simultaneously will overwhelm the Oak engine. The documentation here shows the optimized solution. To implement safe pagination, you add the p.guessTotal parameter to your query string. These JSON responses demonstrate the difference. Normally, Oak calculates exact hit counts by checking access controls on every single item. By providing a numeric value to guessTotal, you instruct the engine to stop counting as soon as it satisfies the pagination limit. Trading an exact count for the guessTotal parameter is the difference between a query that takes multiple seconds to load and one that completes in milliseconds. Building and deploying the index is step 1. Maintaining optimal performance requires active daily monitoring of your repository. This troubleshooting table highlights common query causes and mitigations. If a search feels slow, your first step is using the Explain Query tool in the developer console to verify that your specific query is actually routing to your new custom index. Next, navigate to the JMX console. Here, you can check index stats to monitor the progress of asynchronous indexing and review failing index stats to catch any corrupted data blocks. For deep analysis, you can enable debug logging on the org.apache.jackrabbit.oak packages. Revert the logs back to info level immediately after testing, or the sheer volume of log data will fill up your storage drives. Running through this standard checklist keeps you ahead of the curve, allowing you to catch indexing bottlenecks before they impact end users. We've customized an out-of-the-box index, minimized its footprint by disabling Tika, secured the deployment through Maven configuration, and protected server memory using the guessTotal query parameter. You've moved past trial and error configurations. You now have a verifiable, enterprise-grade database architecture that delivers instant results. With your back-end queries firing smoothly, you're ready to expose that speed to the front end. In the next video, we'll extract dynamic data facets from this index to build responsive UI filtering.